All right, Math 2, here we go. We're going to today do 6.2.1 at your service. This is just kind of like a little word problem to see if we can use our knowledge about right triangles to solve a problem. So we've got, in the game of tennis, every point begins with one player serving the ball, obviously. For a serve to be legal, the player must stand outside the court, so they got to stand out here and hit the ball so it crosses the net and lands in the service box. Okay, so it should land somewhere over here. All right, so if you hit it too low, it's going to hit the net, too high, and it's going to go over the service box and be out of bounds. So it has to go in this kind of gray box when you hit it. All right, so Karina, she's a tennis player. She wants to make her serve really powerful. She wants to hit the ball so hard that it travels in a straight path, because usually gravity would make it curve, but we're going to pretend like it'll go in a straight path. But when she hits it really hard, she keeps on hitting beyond the service box. Okay, so she's going to practice. She realizes that the height that she hits the ball is going to help her decide whether or not she actually makes it into the service box. So how high she is really what's helping her decide if she's going to make it over this net. So the higher that she throws the ball, the better chance she has of hitting into the service box. So what she wants to do is find out how high she needs to hit the ball so that it barely goes over the net and still goes into here. All right, so that's her goal. She's going to hit it so hard that it goes in a straight line, goes over the net, and just ends at that corner of the service box. So we want to find out, how high does that ball need to be? So that's our X right there. How high does that ball need to be when she hits it? All right, so our task is to see where is that ball going to be when she hits it. And we want the ball just to hit the corner over here. Okay, so we want it to hit that corner. So we need to decide, where do we think that she needs to serve from? You might think, oh, she needs to serve from here, or she might need to serve from over here. We're just going to play around with it today. Let's pretend that she serves from like here. This is like the farthest away from this corner. Okay, so if she does that, we've got the start of a right triangle here. From here to here, it says that this is 27 feet. And then this part here is 21 feet. And this whole part here is 39 feet. So that's a total of like 60 feet, right? So a total of 60 feet from here to here. That's 60 feet. All right, so we need a couple things. We need to find the path that the ball needs to travel. So here's the ball traveling this path. So we're looking at something that's kind of three-dimensional here. So I want to find out, what is the total distance on the ground from where she hits the ball to where the ball lands over here. And that looks like a right triangle right there. So I can use the Pythagorean theorem to find out that right triangle that she's going to hit it at. So she's going to hit it from here. This is the path of her ball. So I would just do 27 squared plus 60 squared equals c squared. All right, I'm going to pull out my calculator. So, ooh, low battery. That'll be fine. All right, so 27 squared is 729. 60 squared is 3,600 equals c squared. So 729 plus 3,600 comes out to 4,329. And then I'd take the square root from both sides. So the path of that ball from that corner over there would be the square root of 4,329. I don't think that's a perfect square, but I can check. 4,329. It's not. So we're just going to leave it like that. So that's the path that her ball is going to take. Well, at least that's the path on the ground. Now what we need to do is flip it to a side view, because that's the view from looking down on it. Now we kind of need to look at it as a side view. So here's the court. Here's the net in the middle. 3-foot net. Let's say that she's trying to hit the ball right here. And then she's back here. This is the height that the ball needs to be. So we want a path doing that. So right angle. So this is where her ball needs to be when she hits. It needs to make it over this 3-foot net and then land over here. So what this is showing is this path here. So this is the part on the ground, this path right there. So we know that that entire path is the square root of 4329. So I've got that. Now what I really want to know is how tall is this? Now I've got a couple problems here. Number one, I know that I've got a right triangle, so I might think, well, what about the Pythagorean theorem to solve this one? Well, if you use the Pythagorean theorem, we need two sides, and I only have one side. So that's a little bit of a problem. And you might say, well, what about sine, cosine, and tangent? Well, I don't know what the angle is over here or the angle up there, so I can't use sine, cosine, or tangent. But what I can see here is that net is making a separate triangle. It's making a triangle right here. And then I've got a bigger triangle over here. Now these two triangles have to be similar triangles because they're sharing this angle right here. And then this is 90 and this is 90. So by angle, these two triangles are congruent. So what I can do is a proportion in order to solve for the height. The height of the big triangle over 3, x over 3, equals this over this. So I did all this work to find the hypotenuse there, but really what I want to do is now find out how far this portion is. Just this portion right here. So we might need to use proportional triangles there. We can do a lot of different things right there. All right, so I want you to work on your own and see if you can find out these distances here so that I can use them here and here. All right, I'm going to pause and then I'll show you my work. All right, so I finished mine off. So here's what I did to find this distance here. So that's going to be this distance here. So I called this part x, and I know that the whole thing is root 4329. So I set up a proportion, 21, because this is a similar triangle. So this small triangle here is a similar triangle with this big triangle. So I do 21, that's the small triangle, over 60, that's the big triangle. Then x is a small triangle. And then this whole distance here, we found out was root 4329. So if I do cross products, I get 60x equals 21 times 4329. And then I divide by 60. So there I've got 21 root 4329 over 60. If you want to at this point, you could probably reduce it and then like write it down as a rounded number if you want to. I didn't, but that's okay. So right here, I know that this one, because that's this spot right here, is 21 root 4329 over 60. And then the whole thing is root 4329. So if I want the height, that's from the big triangle, I compare it to the height of the net, 3 feet. And then this entire distance is 4329. Root 4329. And then this small distance here is 21 root 4329. And I wrote times 1 over 60, which is the same thing as dividing by 60. You're going to see why I did that in just a second. Now, the reason why I left it as root 4329 is I noticed that it was going to end up reducing. So now I have 21 and then 1 over 60. So when I divide by a fraction, I'm actually going to end up putting the 60 in the numerator. Because remember the keep, change, flip thing? So if I multiply by a fraction, you can put this up on top. I mean, you could just leave it as a decimal too. It doesn't really matter at this point. So anyways, this 60 went to the top. If you left the bottom as 21 over 60, so like if you did x over 3 equals 1 over 21 over 60, you're still going to get the answer. Over here, you would just do 21 over 60, x equals 3, and then you'd multiply by 180, and then divide by 21, and you'd still have the same answer that you've got right here. So I've got x equals 180 over 21. It turns out that she's going to have to hit the ball from 8.57 feet. That's how high the ball needs to be. Now, let's see if that's going to be reasonable for her to actually hit the ball. Now, it says here that she's 5'7". Okay, so she's 5'7". That's like the height here from the top. So how much do we have left? We've got about 3 more feet left. Well, she's got her arm, and she's got the racket, which is probably 2 feet by itself. So her arm, and at the end of her arm, she's got the racket. Yeah, if she jumps a little bit, she should be able to hit that. Because her head is 5'7". And then you've got her arm, which is at least, I don't know, what, like 2 feet? And then her racket's got to be at least 2 feet or so. So yeah, it should be able to hit it. Yeah. And if she has to, she could jump a little bit. So it looks like it is possible to hit it in there. All right, so we used Pythagorean theorem and then similar triangles using angle, angle. We first found the path that the ball would take. That's this bottom path. So we kind of did it looking top down, and then a side view to help us use our Pythagorean theorem and our similar triangles. And we found out, yep, it looks like she can do it, 8.57. All right, thanks guys. See you later. Bye-bye.